We're still going to deal with conic sections like we were talking about, parabolas, ellipse, and hyperbolas. But that's going to be at the very end of these problems where we end up with one of those and then we graph it. What we were looking at this entire week, and this will be a little bit different kind of week, because today we'll get in and we'll get you the introduction. We'll go through an example where how do you rotate a conic section, what happens, okay, and how do you go through the process. Tomorrow is ACT, so sophomores and seniors have off. Wednesday then we'll come back to this again. I'll go through another example, and then we're going to work our way through it. My plan for this week, and you'll see why by the end of this lesson, is I'm going to give you a quiz on conic sections, but I'm going to make it over 2 days. Okay? Because one of the days you'll have a problem like what we're doing this week, what we're working on. These are pretty long problems. That's one of the reasons why I'm splitting it up. Okay? And then the other part of the quiz that we'll then put together as one grade will be like what you were working on last week. Here's an equation. Do I have to complete the square? Things like that. Is it an ellipse, parabola, those types of things. Okay? So that's kind of where we're at. And then next week is 4-day week. Next Friday is the first day of spring break. So you got the last week of the quarter next week. Okay? So the quiz on these conic sections will be the last big grade going in the grade book for this quarter. Okay? Granted, it's just a quarter grade. It's just a progress report. Okay? Really, that's what a quarter grade is. It just tells you where you're at halfway through the semester. Okay? But just as a heads up. Okay, so here we go. Here's the idea. I'm going to preface today by saying, one, you got to make sure you try to stay as organized as possible in these problems. Two, take your time. If you rush through these and accidentally mess up like a negative sign here or there, or add when you're supposed to multiply, or something along those lines, you're going to see why as we go through these. We're going to take our time and make sure that we're working our way through the process. Then, even though they're related to conic sections, the number one reason why we're doing this right now is it's good algebra practice. Okay? Because as you move forward into whatever class next year, whether it's calculus here at the senior high or it's calculus or something in college next year, there are calculus type of problems that are pretty long and a lot of details that go into that. And so this is kind of your first real practice at seeing something like that. You're not going to have a lot of these, okay? I can tell you that for sure. But we got to make sure we take our time on these, okay? So if you take a look, here's the idea. Here's the general equation of a conic section. We talked about this on Friday as you were taking a look at, in general, x squareds and y squareds, x's and y's, and f is just whatever the constant is, okay? And we've had every equation we've dealt with so far has been some version of this. Sometimes just x squareds or y squareds, which made it a parabola. We said if you got x squareds and y squareds, it's either an ellipse or a hyperbola. If it's the same sign, we knew they were an ellipse. If the x squareds and y squareds were different signs, we knew it's a hyperbola. Okay, and so that'll keep coming back. But where we are headed this week is, we said last week there was something missing. There's a b missing here. Here's the b that's missing. Okay? And what happens when we put that term actually in here is it takes the conic sections that we were working on, and normally when they're stretched, let's say I'm going to use an ellipse for an example, stretched either horizontally or vertically, that bxy term causes a rotation. So it takes that, let's say the ellipse, and it's going to rotate it. So it's no longer just horizontal or vertical, it's going to be rotated a certain degree. And we're going to figure out what that degree is, and we're going to rework the process here. Okay? But that's what that bxy term does. And that's why we didn't deal with it last week, because it makes it more difficult. And so, like I said, we're going to do a rotation of whatever theta is to eliminate that term and get back to what we were working on last week when we finally get to the graphing part. There's two main goals today. One is figure out theta, is how much is the rotation, and number two is in the process, can we eliminate that term so that we can get back to what we were doing before? And that's the process that takes a while. That's what I was prefacing this with. I'll give you a second to write that down if you're writing it down. All right, so if we take a look, here's what's happening in general if we just kind of look at the graph. So normally, here's your x and here's your y-axis. What we're going to do is we're going to rotate this in a positive direction so that it's going into the first quadrant. Okay, so ultimately, that x-axis is going to rotate some positive degree. And let's say this, then I'm going to call that the x prime axis, if you will. We're going to have some primes today. That is the amount that things are going to get rotated. So normally your x-axis is horizontal. We're going to rotate it a certain degree. Today, the degree is going to be based off of the conics, or the unit circle. It's going to be either 30, 45, or 60 degrees. Those are the ones we're going to look at today. When we get back on Wednesday, we'll talk about what if it's not on one of those nice angles. What if it's 27.2 degrees or something like that. And the same thing here then. This then would be the approximate y prime, and again, that would also be rotated the same amount. Okay? So it's basically taking your axis and rotating it some degree. Okay? So that's kind of the visual of what's happening. This you don't have to write down. But, so if that's the equation, here's what we're going to end up. And the same thing, you don't have to write this down. A prime, all the A, B, C, all that kind of stuff, those primes will all be numbers. Okay? But you're going to end up with like some x primes squareds and y primes and all this kind of stuff. Because ultimately, like I said, we're going to try to eliminate that and get back to our usual equation that we've been working on. So, as we do that, here's the first one. Make sure you write this down. There's a couple of main equations we need. In order to find theta, we're going to use this equation, which is really just the quadratic formula is all that is. And if you notice, in this equation, all we need is a, b, and c. A is just the coefficient of x squared, b is just the coefficient of xy, and c is just the coefficient on y squared. So we'll identify those in the problem, and then we'll substitute them in and get an answer. So that's the equation that's going to help us find our degree of rotation. Okay. How much are we going to rotate these conics? And this actually, even though it looks really messy, it's pretty much just a quadratic formula type of problem. You'll see that the numbers and the math behind it are not that bad. Okay. This is not the messy part of these problems. Then the other part is as I go through and I try to eliminate this xy term, I'm going to make substitutions for, in place of x squared, we're going to put something in its place, whatever it equals. In place of the xy, in place of the y squared, we're going to make a bunch of substitutions. In order to come up with those substitutions, we're going to use these two equations. Okay, so make sure you write those down as well. These are the three main equations that we're going to use today. Completely different now. You'll be happy to hear that on Wednesday I'll have the desk back to normal again. The only reason I didn't do it today is because I have the ACT in here tomorrow, so I would have to go right back to this. Otherwise I would have done it today, over the weekend. So Wednesday you'll be back in your groups. All right, so like I said, tangent equation, that's the equation we're going to use to figure out theta. And then these two equations we're going to use to figure out x and y, the new x and new y. Okay? And then we're going to use those equations to find a bunch of other things. And that's what makes this process kind of long. You got one equation for theta, you got one equation for x, you got one equation for y, and then if you go back up, we've got an x squared, we've got an xy, we've got a y squared, we've got all of those types of things, and we have to come up with those pieces for all of them. Here we go. If you didn't quite finish it up, I'll let you finish writing this down, and then we'll get into the details. Are we good? Everybody got it? a couple people still writing. I'll just wait until, because you want to make sure you have these three equations. This is your starting point for all of these problems. Theta, x, and y. While you're doing that, two things I would take out. Calculator and unit circle sheet. You're only going to need the unit circle sheet for a second. But it's something that I think you'll want to refer to. And here is your first, here's the example that we're going to take a look at. So here's your first equation that you've had that does have an xy in it. And so we need to be able to eliminate that in order to see what that rotation is. This is the example we're going to work on today. This example, again, I'm going to preface this, will take us the rest of the hour. I'm not joking. The other class we finished about a minute and a half before the bill. Okay? Huh? There's one problem. This is why I say pay attention to the details today. Maybe even more than a whole page. Here's my work for this problem. These are long. Okay? And again, one of the main reasons why we're doing this is because it's good algebra practice. When you get into calculus, it's not really calculus, the concepts of calculus that are all that difficult. Calculus is based off of slope of a line for the most part. It's the algebra that's in the calculus that gets a lot of people. So that's the main goal of this, is kind of practice through some stuff. So here's our first example. What we need is theta. That's where we're going to start in a second. And then we're going to take this x squared out, and we're going to substitute something in its place. We're going to take the xy out and make a substitution. We're going to take a y squared out. Okay, so we have to make substitutions for those three things. So step number one is find theta using our tangent formula. Okay? So if we notice, first thing we need to identify then are what's a, b, and c in this problem. Okay? So a in this case, we said a is just the coefficient of x squared. That's the 7. B is the coefficient of xy. That's the negative square root of 6 square root of 3. Don't forget the negative. Again, details. You forget the negative in the very first part, you're going to kick yourself 30 minutes from now when you finish this problem. Okay? 13 is the c value. Okay? That's why we're taking our time. So we have a is 7. B is negative 6 square root of 3. And c, what did we say c was? 13? Okay. So there we go. All right. Let's substitute into our tangent formula. Let's take a, b, and c and substitute it in. So tangent of theta equals, for the first part, I'm just going to write it out, and then we'll evaluate from there. So in this case, we have 13 minus our a value of 7, plus or minus the square root of 13 minus 7 squared, plus our b value. Remember, when you substitute things in, put them in parentheses. Okay, so in this case, negative 6 square root of 3 squared, all over the b value, which again is negative 6 square root of 3. All right, so there's our substitution. Now let's start cleaning it up a little bit. Tangent of theta equals 13 minus 7, that gives you 6, plus or minus the square root of. At this point, this is something you could just plug it into the calculator. Just make sure when you plug it into the calculator, you get, again, you put parentheses in. Okay? So what do I get under the square root? What does the stuff under the square root actually equal? Oh, somebody said it. Should be 144. Okay? You should get 144 as your answer, underneath the square root. And then you still have the negative 6 square root of 3. Okay? Again, As you're working your way through and you're putting this stuff in, put it in parentheses. Make sure you're careful when you're typing this stuff in. And now we simplify from here. So tangent of theta equals 6 plus or minus. Square root of 144 is a nice perfect square. We've got 12. And we're actually almost done finding theta. So when you take a look at this problem, once we've simplified, here's one specific part. We said we're going to take theta. We want it to be a positive number. We want to rotate into the first quadrant. That's where we want the x to go. So as you look at this, I'm not actually going to do the plus or minus. I'm going to do only the one that would make this entire fraction a positive fraction. Which means in the numerator, do I need to end up with a negative number or a positive number?
Negative.
I need a negative so that then when I divide by the negative in the bottom, we get a positive answer. That's what you want. You want this entire fraction as a whole to be positive. So I'm going to take 6 minus 12, negative 6, over negative 6 square root of 3. I'm not even going to worry about the positive part. Okay? And now we can simplify. You got a negative 6 and a negative 6 that cancel, and you're left with 1 over the square root of 3. And we are right back to your unit circle. Where does the tangent equal 1 over the square root of 3? What degree? This is a 30-degree angle. There's our rotation. Okay? Theta is 30 degrees. Okay? So this conic section is going to be a 30-degree rotation into that first quadrant. Okay? And it would be really great if that was all we had to do, and then we could go back to conic sections and just say, all right, let me complete the square and work on what we did last week. Unfortunately, that's not how it's going to work. It doesn't work out that way. Okay? Questions so far? Anybody doing okay? Take your time is my biggest suggestion. Be careful. Don't rush these. The good news is, for the homework today, you're going to have one problem, and you've got today and tomorrow to do it. You don't even have school tomorrow. So you have plenty of time to do the one problem. Okay? Wednesday, when you come back, we're going to go over another example. And then for homework, you're going to have one problem. Okay? So it's not like we're going to do 10 of these. You're doing one. You've reached the point of math that one problem is plenty. Okay? All right. So now, here's what we got to do. We said ultimately, let me go back for a second. I need to make some substitutions. I need to pull out the x squared, the xy's, and the y squared. In order to do that, I need to know what is x and what is y actually equal before I can do that. So that's step number 2. Using our equation that we had before, we need to find x. Okay? So x equals, if we're using our equation, we've got x prime times the cosine, but now we know what theta is. It's the 30 degrees times the cosine of 30 minus y prime times the sine of 30. And if we now start substituting in what those actually equal, we know what the cosine of 30 and the sine of 30, that's just off of the unit circle. So we've got x prime times, what is the cosine of 30 degrees? Square root of 3 over 2. Remember, cosine of the x coordinates. So this is square root of 3 over 2 minus y prime. What's the sine of 30? That's the 1/2. That's the y coordinate that goes with it. All right, let's clean this up here a little bit. Let's put this together as one fraction. That means x equals, I'm always going to put the numbers in front of the x's, so we've got a coefficient. So we have the square root of 3 x prime. Over here we have minus y prime. And it's all over 2 because we already have a common denominator. Think of these x's and y's as just over 1. So all I really did is I multiplied those together and then combined the fractions. Okay? And again, let me stop for a second. Any questions? Anything not make sense? Okay? There's x. Because in order to get x squared, in order to get xy, in order to get some of that stuff that we're going to substitute, we need to start with x. What do you think's coming next? Now we got to work on y. There's the next part. using our equation that we had for y. That's why I said those first three are our starting point. Tangent x and y. So we've got x prime times the sine of 30 plus y prime times the cosine of 30. And once again, we already talked about what sine and cosine of 30 are, so we'll plug in the numbers at this point, and then we'll clean it up right away. We've got x prime times a half plus y prime times square root of 3 over 2. Okay. And again, that's just coming off of your unit circle. That's why you needed to find theta right away. Because without theta, you can't find x, you can't find y. And once again, let's put this all together as one fraction. So that means y equals x prime plus the square root of 3 y prime all over 2. Doing okay? Not too bad so far? Okay. None of it by itself is all that bad. It's just that everything compounds. That one based on the next, based on the next, based on the next. That's the idea, and that's why I say take your time and try to just break it down one step at a time. All right, so now we've got x and y. But in our equation back at the beginning, I've got x squared, xy, and y squared, which means that's what I need to find. I need to figure out what does x squared actually equal so I can substitute it in. What does xy actually equal so I can substitute it in? That's what we now have to work on. Okay, so here we go. Let's find xy. Which is just the x that we found multiplied by the y that we found. Okay. So here we go. Here's the x that we found times the y that we came up with. So we're just multiplying x by y. Again, one step at a time. xy equals. When we multiply out the numerators, what am I going to have to do? We got to FOIL. We got to distribute. So, here we go. Square root of 3x times x is just the square root of 3 x prime squared. X squared, if you will. Okay. Multiply the coefficients times the coefficients, the variables times the variables. When I take the square root of 3x prime and multiply it by square root of 3y prime, what's the square root of 3 times the square root of 3? 3. And then x prime times y prime is just that. Okay, so you end up with plus 3 x prime y prime. Okay? When the variables are not the same, you just put them together. Okay? So we took the square root of 3x and distributed that. Now we need to take the negative y prime and distribute that. Negative y prime times x prime is just negative x prime y prime. And then finally, negative y prime, when I distribute, again, coefficients, we end up with negative square root of 3 y prime squared. All over 4. That's the nice part. Okay, we can do that one. Let me stop. Anybody not understand that? Anything not make sense? Okay, let's keep going. Now, as we clean this up, and we'll clean this up right here. In the numerator, which terms are like terms? Yeah, you got x, y's. So we can combine those two terms into one. So we have the square root of 3 x prime squared. Positive 3 minus 1 means I have a positive 2 x prime y prime. And then we still have the minus square root of 3 y prime squared. I found xy. What's coming next? What else do we need to find yet? Let me go back to our original problem. I still need the x squared, and I still need y squared. Let's keep going. See why it's super important that you're organized and super important that you take your time? Okay? You can do this. You can do this. You just need to work your way through and be patient. Okay? X squared. Let's do that one next. Keep in mind, x squared is really just x times x. That's how we're going to get x squared. We're going to multiply it by itself. So it's pretty much the same way that we just got xy. And y squared is going to be very similar as well. So when we multiply this out, x squared equals, if we distribute the first term, square root of 3 times square root of 3, 3. X prime times x prime, x prime squared. That's 3x squared, basically, is what that says. They just happen to have primes on them. When I multiply by the negative y, we end up with a negative square root of 3 x prime y prime. Coefficient times coefficient, variable times variable. So we've distributed the first term. Now we come over to the negative y prime and distribute that. Multiply it by the first part, we get a negative square root of 3 x prime y prime. Negative y prime times another negative y prime is a positive y prime squared. All over 4 again. Okay, so it's a bunch of distributing. Let's clean it up. Which terms are the like terms? Yeah, the x prime, the square root of 3's, x prime, y primes. So as we clean this up, we still have the 3x prime squared. If I put the two middle terms together, how do I put those together? You got negative 2 square root of 3 x prime, y prime. Think about it just as like terms. You've got two of them. So when I put those together, we have negative 2 square root of 3 x prime, y prime. Okay?
Who came up with this? Like, what guy just sat down?
Not me.
Yeah.
Wasn't me, I can tell you that. I can do the math. I would have never come up with this on my own. I'm guessing some engineer.
I don't know who would even sit down and be like,
Here's what I would. This is the average person is definitely not using this on a daily basis. But what I can see this being used as is if you think, I'm going to go back to the ellipse for a second. Not everything is nice horizontal elliptical. Sometimes there's things that spin kind of at a rotation. That's kind of an application. It's kind of an application. So I'm sure there's people that are in NASA that are kind of working their way through and that are using this. Okay? Why you're doing it? It's good algebra practice and it connects to conics. Okay? Y squared. You'll get there. It'll be okay. You got to get past the shock of everything at the beginning. Okay? You'll be all right. All right. So y squared is just y times y. And it's almost identical to what we just did. The only real difference is the signs are different. So again, if we go through and we distribute this, y squared. If we distribute the x prime times x prime is x prime squared. X prime times the square root of 3y prime. Put it together as one term. Positive square root of 3 x prime y prime. Then we take the square root of 3y prime and we're going to distribute that. Square root of 3 x prime y prime. And when we distribute to the other part, square root of 3 times the square root of 3 is 3. Y prime times y prime squared. How we doing? Okay? It's a lot of work, but again, it's all things that individually that you can handle. That's why you take one step at a time. All right, let's clean it up. Let's put it all together here. Y squared equals, there are no other x prime squared, so we can leave that alone. Again, just like the last part, we've got x prime, y primes. We have two of them. So we have plus 2 square root of 3 x prime, y prime. All right, we're getting there. What's that? You can, just as long as you don't start confusing x's with x primes and things. So personally, I would put them in there, but it's not like it's the end of the world. All right, here we go. So now we found we needed x and y so that I could get the x squareds. Now the point that we are at is now we're going to make our substitutions.
Oh, great.
Okay? Now we start the simplifying process here shortly. It will clean up in the end. You'll actually be surprised how much it cleans up in the end. But we are now going to take the x squared out and put in what we found for x squared. We're now going to take the xy out, put that in. We're going to take the y squared out, put that in. Okay? No, it's messy still. We're not past the messy point. Okay? Yeah, see? I have more than a sheet of paper.
There's a graph too.
Yeah, that's the whole point. At the end, we got graph it.
That's so sweet.
This is good, right? You guys are enjoying this? So now we're going to substitute this back in. What should always happen on these problems? The x prime, y prime terms should cancel out. That's why we're doing all of this work, is because in the end, the x prime, y prime should cancel and go away. And then we'll be back to a conic section. All right, so here we go. 7 times. We're going to take x squared out and put in what we got for x squared, which was this. 3x prime squared minus 2 square root of 3 x prime y prime plus y prime squared all over 4. Okay, there's one substitution. Now we're going to move to the next term. I'm going to put this minus 6 square root of 3. And instead of xy, we're going to substitute in what xy actually equals. Okay, what we found. Which was pause here for a second. So you, last thing you want to do is rush. Okay? The last thing you want to do on these is rush through it. This is easily, by the way, the most difficult algebra you've done all year. Easily. Okay? I shouldn't say difficult. It's just it's a long process. Question? What is it's a new x, if you will. X prime is really just a new x. All right, so there's your first two terms. We still have the y squared yet. So I'm going to come down here. Plus 13 times, take the y squared out, put in what y squared equals. Which, what did we get for y squared? Let me find it. X prime squared plus 2 square root of 3 x prime y prime plus 3y prime squared all over 4. And in this case, you can actually take that, just like when we were doing conic sections last week. We always took the constant term and moved it to the other side. You can move the constant term to the other side. So we'll say equals 16. Okay? Almost.
No, we just gotta do a little bit more.
Huh? Hang on. So now, we got all of these multiplied by a coefficient. So think of this as like 7 over 1. Think of this as over 1. All we're going to do is just multiply through in the numerator. Okay? And then the simplifying part starts to happen here. Okay? So this first fraction, we're going to multiply all the numerators by 7. Okay? And then you'll have that over 4. So in this case, we end up with, when we do that, you end up with 21 x prime squared. When we multiply the 7 times the radical, since it's not under a square root, you just multiply the number in front. So 7 times that negative 2 square root of 3 is negative 14 square root of 3. Yeah?
Can you remember what you just did?
Yeah, the 21, that one. I just took the 7 times that. That was all. So now that's what I'm doing right now, is now I'm just multiplying each one of these terms by 7. Okay? So 7 times the square root, number in front then becomes a negative 14 square root of 3. Okay? So there's the next part. Minus 14 square root of 3. X prime, y prime. And then when I multiply the 7 times the y prime, you just get 7y prime squared. Still over 4. That didn't go anywhere because we didn't do anything with that yet. Plus, now we work on the next fraction. This one's a little bit messier because of the radical. They're not all. As a matter of fact, your assignment's not like that, by the way. But I actually think your assignment, the one problem for your assignment today is easier than the example. Okay? So now, as we take negative 6 square root of 3 and we multiply. Square root times square root. What's square root of 3 times square root of 3? 3 times the 6 that's already there. You get negative 18 as your coefficient. Okay? Don't forget the negative from that 6 square root of 3. So, and I put this as a plus sign. I'm just going to put the negatives in the fraction. So you get negative 18 x prime squared. When we multiply by the next term, that 2 is not under a square root, so we just multiply by what's outside. So we end up with negative 12 square root of 3. So the next term would be a negative 12 square root of 3 x prime, y prime. And the last term when I multiply is the same thing as the first term except a y squared instead of an x squared. You end up with a plus 18 y prime squared. One more fraction.
Man, I like this.
Multiply by 13. So we get plus 13x prime squared. When we multiply by the radical, just multiply by the number outside, so that becomes 26 square root of 3. x prime, y prime. And then the last part, you're going to end up with 39 y prime squared, just the 13 times the 3. All over 4, still equal to 16. Okay. Now we start cleaning things up. We're almost there. Okay. At this point, there's a lot of things that would be really nice to kind of clean this up. The simplest one is let's get rid of the fractions. What do we do in order to get rid of the fractions? Just clear and multiply everything by 4. Okay? Including, don't forget the 16 on the other side of the equation. Okay? Now, what happens though when you multiply everything by 4? Nope. Yeah, the 4 goes away. You're just left with your numerators. Okay? So you're not actually doing anything really. The 4s just go away. Okay? So you're pretty much just writing out the numerators. Okay? So if we multiply everything by 4, here's what you get. Here's your numerators, with the 4s being gone now. No denominator anymore.
Brianna missed a terrible day. That's so tough.
She'll hear you say that on the video.
Oh God, yeah.
Yep.
Make sure one make a mistake here. What's in the negative 18x? So is that a prime?
That's a prime, yeah. I started writing it squared. And, yeah. Let's see. Plus. Last thing, you gotta multiply to 16, so what does it actually equal now? Now it equals 64. So all the fractions are gone and it equals 64. Oh, you finally made it. Here we go. Here we go. Here we go. Let's start at the beginning. Let's combine like terms. Looking for the x squareds. We got 21 here. Minus 18 there, so we're at 3. And there's 13 there. So now we've got 16x prime squared. Okay? Which, because those are done, go ahead. All the x prime squared, just combining like terms. 21 minus 18 puts you at 3, plus 13 more. So these 3 terms, we're done. Okay, we combined those. And this is the moment where you know if you made a mistake. Right here.
Oh God, on the test almost spent 45.
This is the moment. If you did not make a mistake, the x prime, y prime should all cancel out. Every time. If you made a mistake, they don't cancel out. Negative 14 square root of 3. Negative 12 square root of 3 is negative 26 square root of 3 plus 26 square root of 3. Those terms are gone. How many y squareds do I have? All the rest, and they add up to? 64. You end up with plus 64 y prime squared equal to 64. All of that work to get to there.
There's got to be an easier way, man.
That's what the first hour said too. Not so much. Now, last question. We have now made it back.
And now we have to graph it.
Now we have to graph it, but the graphing's easy. This is by far the easiest part. First question, is this a parabola? There's 2 squares. It's not a parabola. That means it's either an ellipse or a hyperbola.
It's an ellipse.
Why?
Because they're both positive.
Because they're both the same sign. We just came up with an ellipse that is being rotated 30 degrees. So, let's go to our rotation here. All right, anyway, we made it.
Well, we made it.
Man, that
Question? We'll finish it tomorrow, but on your way out,